In this video, we're going to deduce the structure of C9H13 and introduce a new functional group to look at. So, we've got the NMR here as we normally do. Let's have a look at the formula. We know we've got nitrogen, so it probably is going to be something like an amine or something like that. So let's have a look. Between 6 and 8, we have a benzene group, okay, and it's got a 4, which means disubstituted, okay, and then we go down to this peak here, which looks like a singlet. And it's a singlet, it's quite small, so it looks like an alcohol group. Now the amine groups look like alcohol when they have peaks on an NMR. So, but the difference is they have a 2 by them. They can again go anywhere from here to here, okay. But they have 2. They can have 1 by them, okay. But if it's NH2, they'll have 2 by them. And you can tell the difference, for example, if there's an O or an N. So if you see it and it looks like an alcohol and there's an N there and not an O, you know it's an amine. Okay, so we think we've got an NH2, we've got a disubstituted benzene here. We have got a CH2, CH2, CH3. Now, if you look at the splitting, the peak splitting here, and hopefully you're good at the peak splitting now, you've done enough of the videos or you've done enough in class, you can see that this triplet means that this hydrogen here is next to a carbon with 2 hydrogens on. Well, there's a carbon with 2 hydrogens on here. Okay, and also look, this is a sextet, so 6 peaks. That means that is next to 5 hydrogens on adjacent carbons. Well, 5 is 2 plus 3. So that means that this CH2 is next to this CH2, and this CH2 is in the middle of this CH2 and this CH3, which is a propyl group. Now let's do the table. Let's do the different parts of the table, okay, and let's do the relative peak areas. We've got our 5 hydrogen environments, and let's just go through that n+1 rule again. Remember, that means we have 5 hydrogens on the adjacent carbons. We think because of the relative peak areas, CH3, CH2, CH2, and we think that's an NH2, with that singlet with a 2 by it, we think that's a disubstituted benzene. We do our check in terms of the molecular formula, and we take all of these away from our molecular formula, no atoms left. So we know we just have to rearrange these. So let's put this up to the side and let's rearrange them. So we have disubstituted benzene, so I'll start with that. So here's your benzene. Okay, we know we've got something coming off that end, something coming off that end. Again, it doesn't matter whether you put it here, 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 as long as it's disubstituted, okay, because you're not expected to understand the coupling or peak splitting in benzene. So we think we've got a propyl group, okay, so propyl group is going to be CH2, CH2, CH3, okay, so CH2, CH2, CH3. And we know we've got, and that means we've used that group down to that group. Okay, so every single one of those we have used up. Okay, so we've used up those. We're left with the NH2, which is here. Okay, so that NH2 is disubstituted, so it must be on the benzene somewhere else. So just put it on the benzene somewhere else. As with every video, we go back through and we check that this would actually fit what we've got here. Well, first of all, we have the disubstituted benzene, which would be a multiplet, okay, with a relative peak area of 4, which we see here because there's 4 hydrogens, 1 here, 1 here, 1 here, and 1 here. Okay. We then go to our NH2. Well, NH2, this carbon right here has no hydrogens on it, and you can't couple through a nitrogen or peak split through a nitrogen anyway. So this would be a singlet with a 2. Because we've got 2 hydrogens, which fits here. Okay, we then go across here and go, right, okay, this carbon, again, has no hydrogens on it, so this means that it will peak split to form a triplet. And that triplet will be a 2 by it, so if you look up here, triplet with a 2 by it. Okay, and then this one is surrounded by this one right here, is surrounded by 2 hydrogens here and 3, so that's 5 hydrogens, which means it would be a sextet with a 2, and we see a sextet with a 2 right there. And then the last one, we see a triplet again because it's the CH3 is next to a CH2, this time with 3, which we have up here at the top. So we're pretty sure that is the right answer. So the last thing to do though is you've got to make sure you get all the marks in the exam. And you'll notice here that the CH2s, it's not specific which CH2 you mean. Do you mean that CH2? Do you mean this CH2? So you have to be more precise. So all you have to do is take a chunk of the molecule out and put something next to it so you know exactly which CH2 you've got, and then highlight the H's that you want. So, for example, I know this CH2, the sextet, is next to a CH3. There's no other CH2 here next to a CH3, so I can just put CH3. Notice I haven't highlighted the H there. Okay, is next to this CH3 is next to CH2, and the CH2 is giving the signal. We then go to the next one, and this time I want to do this CH2, this triplet of a 2. Okay, well that's next to another CH2, which I've already assigned here. So what I can do is just put it next to that CH2 and then highlight it again. Okay, and that makes it unambiguous. So just be really careful if you've got any structure where it could be ambiguous. You've got two CH3s, for example, or you've got two CH2s and things like that. You might have to put a bit extra part of the molecule in just to make sure you get all the marks. In this NMR, we have looked for a singlet with a relative peak area of 2, which will usually mean an amine if in the molecular formula you see a nitrogen. So the molecular formula will give you a big hint about that. Okay, and you'll see this normal peak here that's slightly small and has a wider bottom with a 2 relative peak area on it. Okay, and in our one today, you saw that with this. And you also saw a di-substituted benzene, okay, with only 4 as the relative peak area, which gives that weight, and a propyl group. Also, you can have a singlet with a relative peak area of 1, which would mean an NH. Look exactly the same, just with a 1 by. And they're just 2 types of amines that you should look out for.